Okay, that's question 7. A carton is in the shape of a large cone with a small cone removed. So it looks as if the bottom bit's been removed. The large cone has a diameter of 32 and a height of 24, and the small cone, diameter of 18, height of 13.5. Calculate the volume of the carton and then give it to two significant figures. So if we got 5 marks, right, this is probably about as much as they ask you anyway. Back in the day, you used to get 7 and 8 mark questions, but I think now this is about as much as you'll get. So, and again, 5 marks, I would be thinking this is great. I've just got 6 marks for the standard deviation question and 5 marks for volume. That's 11 marks on a 50 mark paper. That's brilliant. You know, for doing again what is going to transpire to just be plugging into equations you're given. That's brilliant. Yeah, that's over a fifth of your paper. You know, that's you at like over 20% just for these 2 questions. You know, 5 and 6. I think that's fantastic. You know. So yeah, again, smiley faces if you see a question like this. So if you're not very good to memory, I've got a terrible memory as well. Okay, if you see volume, just go up to the top and say, right, what have I got? I've got a sphere. I've got a cone. Oh, there we go. They're giving you the cone. Okay, and they've got pyramid as well. Okay, but I know cone. So actually, it's not that hard to remember the cone. Okay, I always think a cylinder is pi r squared, which is that's just pi r squared, the circle area, times the height. Okay, that's the volume of a cylinder. So pi r squared h is a cylinder. But if you were to kind of put this into a cone, so say the same base, say the same circle, okay. Sorry, let me do that. If you had the same cone, the same kind of height, right, that is 1/3 of the volume of this. Okay, so that's all that equation means, and I think that's quite. To me, that always kind of helps me remember it. I always think, well, I can remember pi r squared h. That's fine. And then for a cone, I just think, oh yeah, it's 1/3 of the size, isn't it? But yeah, you're given it anyway, right? So you know, who cares? But just that might stick with you because I think as you get into higher, that might not be a formula given. Like I can't remember, but yeah. So that's my given formula. So I'll just write that up here. Right, volume of a cone. So that's 1/3 pi r squared h. Right? And now we're trying to work out the volume of the carton, which is um, the big cone take away the smaller cone, isn't it? So hopefully you recognise that they do even say it's the large cone and the small cone. Okay, they never actually had to say that. They could have just given you these dimensions. But yeah, so you should be thinking I'm going to do this big shape take away this small shape. Okay, so I'm going to say V. Let's think the volume of the carton is equal to V1 take away V2. Okay, V1 is equal to the big cone, and V2 is equal to the small cone. So that's what I'll be thinking to get me going. Okay, and then I'm going to do 2 formula. Doing V1, I'm going to do V2. All right. So I've got R and H for both. So the big one, I've got a 32 diameter and a height of 24. So my radius is going to be half of that. So that's going to be 17. Sorry, 16. And half of this is going to be 12. So equals pi r squared h equals pi r squared h. So that's pi times 16 squared times 24. Sorry, yeah, sorry. I was halving that, so sure you're not halving that, sorry. You half this one, so that's 16, and this is just the full height, so I don't know why I was halving that. I was just in a dream there, sorry. It's a nice day outside, I'm obviously thinking about the sun and all that stuff. 18, half of that gives you 9, and then the height is 13.5. Okay, so like I said, you're getting 5 marks for not a huge amount. I would say this so far has been pretty straightforward. Let's just do volume 1 in the calculator, shall we? Oh, sorry, classic mistake as well. I've not written my formula correctly. Don't forget your third. It's just because I can only see some of that. I've kind of that's jumped out of sight for me. Sorry. So yeah, 3rd pi r squared h is your formula, and then we're just substituting in. The radius is half the diameter, and the height's the height. Okay. So the volume of the big one Put that in the calculator. It should give you 6433.98. Okay. And for the small one, it's going to give you 1145.1. Now, if you're interested in units, which we're not really anyway, that would just be in centimeters cubed just now, but we don't really care. So that's our two values. Now let's take them away from each other. Again, I would just maybe, you could write 6433.98, take away 1145.11 if you wanted. That's going to give us, yep, 5288.87, and that is indeed in centimeters cubed. So that's the volume, so we're almost there. The last bit is two significant figures. So what are the two significant figures in this? So there's our two significant figures there. And like I always say to the kids, you find your place, which in this case is our last significant figure. Look next door, which is 8. 5 or greater, add one more. Now that is greater than 5, so we're going to round that up to give us 5, 3, and then we add in 2 zeros to give it place. Okay, if we don't put the zeros in here, we'll get no place value, we just get 52, which makes no sense. Okay, we do not write 0.00. Okay, we lose marks for that. If it's a money question, I think actually you can still write 0.00 and you're okay, but just be wary. If you put zeros after the decimal point, usually that's taken to be significant figures, and you'd be penalised. Okay, so don't put the 0.00. Right. So it's 5300 centimeters cubed. Right. So apart from me missing out the third on there, I was writing through it. That was pretty straightforward. Okay, if I just written this equation before, I don't know where to recognise that. So yeah, you're using an equation you're given, you're substituting in. Is there even a hard bit of this question? Knowing the radius is half the diameter? I mean, there's nothing much in that, I don't think. Alright, so what are you getting your first mark for? For notifying two volumes, you get a mark. Okay, you get a mark for doing the small volume and the big volume. Okay, that's the big one, that's small. You then get a mark for working out what that actually is, and then a mark for rounding. 5 marks. I mean, fantastic. Happy days. Okay, brilliant. Okay, so we're getting into the halfway point of the paper now, and we should be feeling pretty confident, I think. Here we go, a set of step ladders. Right, classic. So ladders 150 and 140. So that's shown on the diagram below, isn't it? So we just go to that. When it's fully open, the angle is 66. Calculate the size of the angle between the shorter leg and the ground. Okay, and again, if none of this was drawn out, I'd say, oof, trying to draw that's a wee bit tricky, all right? But all that is given, okay? So it might as well just say that. That's what this question boils down to, okay? Now, when you see angles and lengths, you should instantly be thinking about the cosine of the sine rule, all right? Now, if you've got 3 lengths, so say you know 2 and you're working out 1, or you're given 3, that's the clue for the cosine rule. If you've got 2 angles and 2 lengths, that's your sine rule. Okay, so we're going to say A over sine A is equal to B over sine B. Now you notice that we've got capitals and not capitals. That's because if you were just to label up a standard triangle and give it sides, say A, B, and C, the corresponding angle for that length is capital. Okay? Yeah. So that's the only thing you need to know about using the sine rule, is that the angle that you use is the one opposite the length. Okay, so we'd use these two together and use these two together. It wouldn't be permissible just to say, well, use any old angle. It has to be the opposite ones, and the clue's in the name. Okay, it's A and A, and the in this convention, that's the opposite angle. Okay, so doesn't matter what you call A and what you call B, but as long as you use the opposite angle with the opposite length. So let's start off with 140 divided by sine of 66 is equal to 150 divided by sine of x. That's when you just substitute this formula in for these numbers. And then once I get sine x on its own, so I think at this point I would just cross multiply. Okay, put this up and put this up. So what I'm doing is I'm timesing both sides by sine of 66, and I'm timesing both sides by sine of x. So to do it in one step at a time, I basically said 140 equals 150 divided by sine x times sine of 66. Yeah, so to undo, divide by sine of 66 times it, and then actually to move the sine x, I just do the exact same thing, but on the other side. Okay, so I'm dividing by sine x on this side, so I'm going to times by sine x on this side. Okay, that's quite messy. I'm just going to rewrite that. I've not left myself nearly enough space there. Times sine of x is equal to 150 times sine of 66. Again, I do apologise for handwriting. That's annoying me, but sorry. Okay, and then the last one, just to get sine x on its own. On this side, I'm timesing by 140, so I need to divide by 140. And again, just to see the mechanics of this, if you want to undo times 140, I need to divide both sides by 140. Okay, so it means that it disappears on this side because it cancels, and it appears on this side as a different sign. Okay, I go through this a lot in the videos, so sometimes you'll be like, yeah, I know how to rearrange, that's fine, but I always worry if someone just tunes in, they might think, well, what's he doing here? So it does get a bit repetitive for me as well, sorry. But yeah, if you want to move something over, you do the opposite. Okay, so to move times 140, I divide by 140. But what I'm actually doing is dividing both sides by 140, and then that cancels. Okay, so sine x is 150 times sine of 66 divided by 140. So let's get our calculators out. Okay, so sine x is equal to 0.979 around it. So then to get x on its own, to get x on its own, equals, I need to do the inverse of sine to both sides. Okay, so x is equal to sine to the minus 1, or shift sine as people call it, that's what you do in your calculator, of this. Okay, so 0.979, and that gives me 78.2 degrees. Now you could have just done that in one step. That's totally fine. I've just done it in two. You wouldn't get penalised for that, I don't think. Yep, so you get a mark for this point, a mark for rearranging to sine x, yep, and then a final mark. Okay. So yeah, a lot of people might struggle at the end there, but the opposite of sine is shift sine. So again, what I've effectively done there is I've said I'm going to do sine to the minus 1 of sine x, and then sine to the minus 1 of this side. Okay. On this side, and then cancels out. Okay. But yeah, if you're going from sine x equals something, it's shift sine to undo that on your calculator. All right, which is the inverse of sine. Okay. Do you have time? Yeah, I do. So if you imagine your sine graph, okay, like this. So you know it's got a period of 360. It goes up to minus 1 and down. Sorry, up to plus 1 and down to minus 1. So what we've said is sine x is equal to basically 1, haven't we? So we've said it's nearly equal to 1. So it's going to be in about here somewhere, isn't it? Yeah, which is, we know that's 90, we know it's going to be just before 90. So that's kind of what we've worked out, okay? If I zoom in on that. Okay, so we know this number, the 0.979, and on the graph on sine, that's going to be about there somewhere. Okay, and if we go down, that's given us, we're just before the 90 point. Okay, so 78.2 looks good to me. And, very last thing I've forgotten actually, just put your degree sign in there as well. Okay, so good stuff, guys. I hope that was helpful. 2 lengths, 2 angles, sine rule. Okay, again, easy marks there. Easy marks.